In today's lesson, we're going to be talking about the probability of multiple events, and we're going to compare the difference between how you find the probability of independent events and how you find the probability of events whose probability, one of them depends upon the previous situation. So let's get started. Events are considered to be independent if the occurrence of one event does not affect the probability of another. Does not affect the probability of another. And the way that we find the probability of two independent events happening, oh, that's nice. I'm not sure if you could see, but I had a little notification show up on the screen. So, where was I? Here I was. The probability of event A and B happening can be found by finding the probability of each event and multiplying them together. So some activities where the events are always independent of each other, you can think of, tossing a coin and drawing a card from a deck. In fact, most events, I think that we could think of, would probably fall inside the independent events category, unless there was something about the structure of the problem that led us to think that the probability of the second thing happening was affected by the first event happening. And we're going to see an example of that later on. But as for another example, we want to know the probability of spinning a 3 on this number spinner and then spinning a 5. Now, it'd help if this number spinner actually had some sort of pointer on it so we could actually spin it, but I think you get the idea. Anyhow, the probability of spinning a 3 first, there is 1 3 here on the spinner board, and it appears that each of these spinner sections have an equal area. So as a result of that, the probability will be 1 out of, and it looks like we've got 10 sections, 1 out of 10 of getting a 3. So the probability of getting a 3 and then a 5 is 1/10 times, getting a 5 would be 1 out of 10 as well. So the probability of getting both of those things would be 1 out of 100 or 1%. Next up, the probability of spinning an even and then a 7. So on this spinner, 0 is an even number, and so is 2, 4, 6, and 8. We have 5 out of 10 sections. And then a 7, well, there's only a 1 out of 10 chance of doing that. And so we've got 5 out of 100, which simplifies down to 1/20th, or 0.05. So those are some examples, couple examples of independent events. Events are considered dependent when, as you can guess, they depend, one of them depends on the other. If the occurrence of one event affects, I combined those two words there, didn't I? Affects the probability of another. And so the probability of A and B happening in this case is first find the probability of A happening and then multiply it by the probability of A happening followed by B. Excuse me. So in this next example, we have 2 cards drawn from a standard deck. First, you want to find the probability that an ace is drawn, then replaced in the deck, and another ace is drawn. So the probability of event A first, drawing an ace. Well, there are 4 aces out of 52 cards. Then the probability of the event B happening after A. So after the first ace is drawn, it gets replaced into the deck. So because of that, we have 52 cards in the deck again. Then another ace is drawn. So at this point, since we put that first ace back, we have, once again, 4 aces in the deck. Now, instead of multiplying 4 by 4 and then 52 by 52, I'm going to simplify each of these fractions. 4 50-seconds is 1/13. And so multiplying them, we get 1 over 169, which is very low probability of drawing 2 aces in a row with replacement. Now in this example, we've got a spade drawn, but that spade is not put back into the deck. That's going to change the probability of our second occurrence. So we draw a spade, and now there's going to be, there's 4 suits in the deck, meaning that each of the suits has 13 cards. So there's 13 spades out of 52 cards. Next, once you draw a spade and don't put it back in the deck, you're only going to have 51 cards left in the deck. And then the probability of drawing a heart, there are 13 hearts in those 51 cards, so that number would still be 13. Now, before multiplying, I'm going to change this 13 over 52 to 1/4, and then multiply, and so that gives us 13 over 204. And let me give a quick check and see, can we simplify this? Now, I know that 1 and 13 are the only factors of 13 because 13 is prime. So all I've got to do is check and see, does 13 go into 204? Now 13 times 10 is 130. So I'm just going to go up by 13s, 143, 56, and so on. And I can see that, nope, it doesn't go into 204, and so that fraction is in simplest form. It looks like that's all we have for this lesson 3. I'll see you in class. Take care till then.